Hello everyone, I'm Thomas Burnichon, part of the CTO office at ATEM. I'm here to present you the work of my colleague Nikolai Tverdokleb and Thomas Guyonnet, who worked with Kenneth Anderson over at Ericsson to give you some insight on the perceptual quality performance of variable resolution encoding, specifically in VVC and using the reference picture resampling tool. So let's start by kind of setting the stage with RPR. For those of you who've been around for some time, I think Benjamin Bross 4 years ago gave us a good primer on RPR, while even before its standardization in VVC. So VVC got standardized in 2020. It's a traditional codec with temporal prediction, so inter. That's well known. What was new, and specifically in a base codec definition and not in its scalable extension, is inclusion of a tool called reference picture resampling. And basically what that tool allows is for a B or a P frame to reference another frame that is not of the same size. And that was not possible in the base AVC, in the base HEVC, and that unlocks a lot of potential. Actually, it could arguably be described by one reason why versatile video coding is true to its name, because it does indeed include versatility benefits. So let's go through some use cases for this new tool. The first one is network adaptation. When you do video conferencing, you always run into network constraints, and at some point you need to reduce rate. You end up usually reducing resolution. And that's exactly the worst time possible to send a fat iframe down the pipe. You don't want to do that. And with RPR, you can actually directly move to a lower resolution, still reference the old frames, so still use a P or a B frame, and avoid this peak you see here, the red peak that makes things worse when you try to adapt. Another use case for RPR is cross-profile OpenGOP. So in an adaptive bitrate scenario, you want to be able to move between profiles. And the overwhelming use in the industry is to put IDR on the first frame of each segment. So not just an iframe, but an IDR that basically means that every frame in this segment can't reference older frames. And with RPR, you can break away from that. This IDR has benefit. You can obviously move between profile. You can do seeking. But this has a very big video quality impact, especially if you do fixed segmentation. You have your segment boundary at arbitrary points. And some of you in attendance might remember that if you have a scene cut right before those segmentation points, you basically send the same image twice, more or less. That's just plain stupid and inefficient. With RPR, you can see on the line here between segments that you have now those arrows between segments that allows you to efficiently refer older frames. In my example, a scene cut that might happen even a couple frames before. So that's really important for VQ. Of course, that doesn't solve you the problem of seeking. So you still need an IDR from time to time, but you might not want them every 2 seconds, which is a bit brutal. Okay? Moving on to a third use case of RPR, it can be used for rate control. So we've seen this week again that content nature is really important in encoding. You want to be content aware. So for a given bitrate, you want to select the same picture size based on the content. So it's well known, but in fact it was very discussed over the last few years in the context of adaptive bitrate deliveries. But that's nothing new. The same principle apply even if you do a single stream delivery. And with RPR, you can leverage that idea. And when you move on to more complex scene, instead of just increasing the quantization parameter to get your bitrate in check, you can now choose to also reduce the resolution. So basically, you have one more lever to play with in your encoder besides quantization. You can play with resolution. And that opens up a lot of perspectives. Moving on. Now we are getting to what Kenneth brought last year to VTM. So interestingly, VVC, including RPR, got standardized 2 years ago, but in Q4 last year, new tools got added in the reference implementation. And that's a good testament that you don't get a new snapshot every 10 years with a new codec. You actually have a gradual improvement. And this is a good example of how we can creatively use new tools and be efficient. So what does he do in that tool? Basically, he is deciding every GOP, so every 32 frame by default, if he wants to reduce the resolution. And to do that, he needs to quantify the impact based on the content characteristic. And he does that by doing a round trip by a down sample and up sample and measure PSNR. So PSNR is not quite dead yet. And based on this score, he compares it to thresholds. And those thresholds change based on QP. Basically, the more you quantize, the more likely you are to go to lower resolution. And there are 3 thresholds. And if you exceed the highest one, you move to half the res, and then 2/3 of the res for the second, 4/5 of the resolution for the third. And those thresholds get changed based on QP. My point is, based on that, we can decide when to go to lower resolution. And of course, the quantization of those sub-resolution gets reduced. At half resolution, it's -6. So that you keep with a roughly adequate rate control. But long story short, that implementation showed up to 10% bandwidth saving, and that's huge. It's not. Sometimes we get excited, but by a few percent. So 10% is really big. So in that paper, we are trying to evaluate real-world quality impact, exclusive subjective impact of use of that tool. So what we set up to do is to use 5 reference clips and 5 internal clips, 1 on Formula 1 and 4 of football. Depending on where you live in the world, I'll let you decide which one is the right football or not. But based on all those, we first encoded them as an encore without use of RPR at those 5 QPs. And then we proceeded to use the RPR tool, and we had to do some rate matching to make things comparable. Of course, when you do quality evaluation, you want to set everyone on an equal footing, which is what we do, and it's typical industry practice for rate matching. In this first example, for example, while the encore is at 37, we encode at 36 for the first 30 frame, and then we move on to 37. And by those small adjustments, we are able to have a roughly same size file that people can compare and tell us what they prefer. And by the way, that means that in that case, the only small adjustment means that the default parameter by Kenneth were pretty spot on. So first thing first, we confirmed that in our encodes we were seeing resolution gets reduced. That's a good sign. It's kind of a sanity check. What we confirmed is that when you move to more complex content, you actually move to lower resolution. Again, expected, but good to check. And also what we confirm, if you compare the 2 tables, is that when you move to higher quantization, you also move to lower resolution. Again, all that is expected, but first thing first, let's do some sanity checks. Now, in terms of objective performance, the results are quite good. So again, some PSNR, but also multi-scale SSIM test. And we confirm in our sampling that gains were significant and from 3% up to all the way up to more than 20%. But then, and I encourage you to read the paper, we are getting to the real key question of our work is that actually noticeable? Because we all know that those metrics are not alpha and omega, there's more to it. You need to actually check visually what's going on. So we conducted some standardized testing using industry practice, dual stimulus. We had 37 viewers, three setups, everything made as equal and random as possible. And basically what we witnessed is excellent result. Out of the 20 test sequences, 19 were deemed better with RPR, and actually the only remaining one was neutral, not even detrimental. So that's already encouraging. But as in the previous paper, we need to check that this is on sound statistical founding. So at a 95% confidence interval, we show that we have 11 clips that are still statistically speaking meaningfully better. And again, same thing, the lower you go in terms of bit rate, the more useful it gets, which is very promising for us. Compression is that in the real world work at the edge as low in terms of compression as possible. And moving on. Yeah, out of those 37 people, some there were experts in compression, so it was also interesting to get their views on what was going on. And the first thing interesting to see is that they confirm that it's better for them. Less compression artifacts, more stable quality perception. And what's also, and was a key aspect, is that it's stable. In the industry, once you see things like iframe beating, you can't unsee that. You keep seeing them time and again. That tool, at first, raised some eyebrow with the potential of triggering visual change when resolution change are triggered. Well, the good news is that we did not see those changes in our test. And that's, even for expert viewer, they didn't notice the difference. The only time where you do see something is when you have logos and small text, and when you go to the extreme half resolution tuning. But this was kind of expected. There's no magic. At some point, you hit the limit, and there are workarounds about that. So the overall feeling, even for expert at that time, is that this tool is really interesting moving forward. And as a conclusion, I will recap that we noticed objectively impressive bitrate savings, that subjectively it's clearly beneficial. We did not even find one case where it was detrimental, even anecdotically, so that's really a good start. And experts reached the same conclusion and felt specifically that the resolution change were seamless, which was a kind of concern at first. So moving on, we can work to play with more settings. The settings in that model were kind of conservative, so the encouraging result pushed us to test the limit and see when it will start to break down. We can adapt that to dynamic GOP selection. We can maybe change the resize ratio or avoid some of them when we see logos or small text, those kind of things. And finally, I'll conclude that we also encourage all the ecosystem, and especially the decoding manufacturer, to engage on that feature to make sure it works. Again, it's based on the default standard, not an extension, so it kind of needs to work. But we've seen in the past with tools like FGS that even if it was in the base standard, that's not always well supported. So check that out, test the limit of it, engage with us if you want. We can get you test samples. And yeah, because moving forward, this tool will become more and more important. Any question?
Okay. Yeah, quick, please. No, yeah, microphones are open.
So how do you decide which resolution to use for every 32 frames? Do you do two-pass coding?
So no, it's done every GOP. There's more detail in the in the paper, but that's really that logic here, where the first frame of the gob go through a down sample, up sample, get scored. So you can, with that, you can define how prone it is to react to resizing. You compare that to thresholds. Those thresholds are actually adjusted based on QP, so that it's easier to go to lower rate when you increase the quantization. And
Okay. So
Yeah.
you are using hard threshold.
I'm sorry.
You are using hard threshold based on the PSR.
Yeah.
Okay.
Okay, thank you. And another quick question is from me actually. Why are you using so high QP values?
We ranged.
Your range is quite high. It's not typical range, so because it will be like you're assuming it will be more easier to evaluate the results by using low bit rates.
So again, in our use case, our customers are looking for the maximum compression. So it's important for us to look at those. We did a range and then selected 2 for the visual test because, I mean, it takes time to do a visual test, so you can't test everything.
Yeah,
So
I mean,
that's
like
the
base QP is like 37, 40, 43, 46, 49. Are quite high.
We wanted to test the limit when things start to get tough.
I understand. Okay.
So, quick question: Do you see significant differences when you're applying this to 4K versus 1080p?
It's clearly a domain we need to investigate more. That was the first step to kind of confirm our expectation and also make clear, including to the industry, that this has potential. It needs to be tested more in more use cases, for sure.
Thank you very much. Thank you.
Thanks.